This is a 3D replica of Gay-Lussac's earliest experiments, the hot air balloon. To assemble the replica of Gay-Lussac's hot air balloon, take one helium balloon and a small little crate at the bottom for the base of the hot air balloon. Gay-Lussac made an ascent in a hydrogen balloon with John Biot on August 24, 1804. The primary objective of the ascent was to see whether the magnetic intensity at the Earth's surface decreased with an increase in altitude. They concluded that it was constant up to 4,000. Gay-Lussac made his second ascent on September 16, 1804, but this time by himself in order to reach a greater height and lessen the weight of the balloon. He had attained an altitude of over 6,000 meters, and he considered his second ascent as more reliable in terms of Lussac and John Biot established that there was no change in either the composition of the air or in the Earth's magnetic force at the heights they reached. Gay-Lussac law. This law, formulated by Gay-Lussac during the early 1800s, states that gases expand equally with the same temperature, provided that the pressure stays constant. The Gay-Lussac's law is a direct mathematical relationship. This means that there are two connected values, and when one goes up, the other also increases. The mathematical formula of Gay-Lussac's law is P divided by T equals K. This means that the pressure-temperature fraction will remain the same value as long as the volume and amount remain constant. P1 and T1 be a pressure-temperature pair of data at the start of an experiment. If the temperature is changed to a new value called T2, then the pressure will change to P2. It is important to know that PT data pairs obey a constant relationship, but it is not important for us what the exact value of this constant. We know that P1 divided by T1 equals K, and we know that P2 divided by T2 equals K. Since K is equal to K, we can conclude that P1 divided by T1 equals P2 divided by T2. Example 1. 10.0 liters of a gas is found to exert 97.0 kPa at 25 degrees Celsius. What would be the required temperature in Celsius to change the pressure to standard pressure? The step you must do is change Celsius to Kelvin. To do that, you must use the equation C equals K minus 273. So input your data. 25 equals K minus 273. And then add on 273. So you get that K equals 298 Kelvin. You consider that the standard pressure in kPa is 101.325. Now you must put all this into an equation. So 97.0 kPa over 298 Kelvin equals the standard 101.325 over X. The answer is 311.3 K, but the question asks for Celsius, so you must subtract 273 from 311, and you will get 38.3 degrees Celsius. Notice that the volume never enters the problem. That is because the problem is asking about the relationship between pressure and temperature, and volume remains constant. An in-depth look on Gay-Lussac law, and these are all the greatest achievements and discoveries Joseph Louis Gay-Lussac has made throughout his life in chemistry.